Okay. Good afternoon, Pascal.
Good afternoon,
Good afternoon.
ma'am.
Good afternoon, ma'am.
Good afternoon, ma'am.
Okay. Thank you. It's nice to see you today, though virtually, and I hope when the situation gets better, we'll be able to see each other again face to face. Before anything else, kindly lead the prayer, Michelle.
Ma'am. Okay, let's pray. Lord, salamat po sa araw na ito. Nawa po ay marami kaming matutunan. Gabayan niyo po ang aming guro sa kanyang pagturo ngayong araw. Yun lang po, maraming salamat. In Jesus' name, Amen.
Amen. Thank you, Michelle. Now, Hernil, can you check our attendance for today? How many males and how many females, and the total number of attendees for today's class?
We have four boys and six girls, a total of 10 students.
Okay, thank you so much, Hernil. So, we're done with the prayer and the attendance. So, before we start with the game that we're going to play later, I'll first discuss with you the netiquettes or the etiquettes that we have to observe the entire class. Number one, be prepared. Find a quiet place and comfortable place to study. Mute and video on. However, I understand that in Pangarap, there's not a very good connectivity or connection. So, if you have to mute and turn your video off, I will understand. Next, raise your hand if you want to talk or send a message in the chat box. Don't talk when others are talking. Wait for your turn. Be respectful and kind. Listen, participate, and enjoy. Are we good with this etiquettes, Pascal?
Yes, ma'am.
Po,
Okay.
ma'am.
Thank you so much. Right. So today we'll be discussing about rich push and slab pull. We have three goals for today. The first one is to discuss how ridge push and slab pull cause plate movement, which we are always affected when there's plate movement because there are earthquakes and etc. Number two, simulate the mechanism of ridge push and slab pull using paperclip or chain experiment. And lastly, recognize ridge push and slab pull as driving forces for this plate movement. Let's begin. Are you excited with our game?
Yes, ma'am.
Uh,
Ma'am.
okay. So this game is called the reading rebus. So here are the instructions that you have to follow in order for us to play the game properly. Number one, you'll be grouped into. The points of each member will be accumulated as the group's point. Number two, this is a race to three. So the first group to score 3 points wins. Three, perform the indicated operations to find the unknown word. So there are two indicated operations there, the subtraction and addition. Later on, I'll be giving an example. Number four, type your answers in the chat box with the format group number space your answer. So if you're group one, you write one and then your answer. If you're group two, you write two and then your answer. So here is an example. Here's a practice item. So decode this reading rebus and send your answer on the chat box. All right. So it seems to me that you're very familiar with this game already. So for this one, the first to type in her answer is Christine Betare. So one, Earth. So that's the correct answer. So this is just how this game works. So let's proceed. So the first item, number one. Okay, so I've been seeing answers already. Ang dami nating keyboard warriors. Number one goes to group 2. The correct answer is ridge. Very good. So, next item. Okay, so very good. The correct answer is push. And the point goes to group 2 again from Ephraim Pudol. Okay, next item. Group 1, habol kayo. So, group 2 already has 2 points. Group 1, 0 points. But still, makakahabol pa rin yan. Number 3. Okay, so from Christine Betare. So, group 1, the correct answer is slab. Ayan. So, good job, Christine. So, for group 1, you already have 1 point. Group 2, you have 2 points. Next item. Okay, so we now have a winner because group 2 was able to answer. The answer came from Hernil Hernandez. He was able to answer Paul. So, group 2 answers Paul. So now group 2 has 3 points. Group 2 wins. Nice sport, group 1. Good job. Let's give group 2 3 virtual claps. Okay. So for this is for the fifth item. This should be a tiebreaker in case you'll have 2 points each. So for this one, you have play button minus y plus kite minus ki equals as the first word, and the second word is money minus ney plus stove minus sto plus mentos minus os. So the answer there is plate movement. But hindi na nga tayo umabot dyan because group 2 already wins. Good job, everyone. Congratulations. All right. So before we do our activity, let's have a little recall first. So plate tectonics theory. What does this theory state? Can you give me your idea about this theory since we have already tackled this one? Ephraim, can you share your knowledge about this?
Yes, ma'am. The theory of plate tectonics states that the Earth's solid outer crust, the lithosphere, is separated into plates that move over the asthenosphere, the molten upper portion of the mantle. Oceanic and continental plates come together, spread apart, and interact at boundaries all over the planet.
All right. That's exactly on my PowerPoint as well. So it states that the outer crust, the crust, I must share with you, there are two kinds of crust, the oceanic and the continental crust. The continental crust is where we're standing right now. That's continental crust, which makes up the 7 continents. And then the oceanic crust is underneath on the ocean floor. All right. So that ocean floor plus the continental crust, they make up the crust or the lithosphere. Now they're separated into different plates, which is stated in the plate tectonics theory, and they are moving. And that's the reason why we're experiencing earthquakes and other geologic processes. Now, the big question here is how? How does the plate move? What causes these movements? Now, that's what we're going to find out today. So, for that, let's do our first activity. Activity 1, ridge push. I've already told you to prepare the materials. Our objective for this is understand the concept of ridge push. All right. Estonina, kindly read the procedures for this activity. Janice. Seems like Janice is having some connection problems. Bitare, kindly read the procedure for this activity.
Procedure. Create a right triangle using your folder. Label it as the mid-ocean ridge. Number 2, create a chain by using 10 paper clips or just use necklace chain. Label one end as old ocean crust. Put the chain as a slanted side of the folder at one-third length. Slowly add chains. Observe the answer the guide question.
Okay, thank you, Christine. So your setup should look like this one. So here I put a side view of the folder since the folder here looks flat, but it should not be flat. You should have an inclined plane in there like the hypotenuse of a triangle. And here is your chain at one-third length. And then you have to label the end of the chain as Old Oceanic Crust and your folder as the Mid-Ocean Ridge. And then slowly you're going to add chains to the old oceanic crust on top of the mid-ocean ridge. So here are the guide questions that you should take note of and answer while doing the activity. Later on, this will be very important for our discussion. So, Kapundan, kindly read the guide questions, please.
Questions. Number one, what does change 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 being added represent? Number two, what happens to the paperclip they old oceanic crust when you slowly add the chain? Number three, what does new chain do to the old oceanic crust?
Okay, thank you, Michelle. Now I'll be giving you 3 minutes to do this activity. It's 2:22 at 2:25. We will proceed with the next activity. So just take your time to do and observe what happens on the activity and your the answers to the guide questions. Maybe you can write it on a piece of paper so that later on in our discussion, you know what to answer and we will be able to process the idea or the concept of rich push properly and in a fast manner. Okay, you still have 1 more minute. After that, we'll proceed with the next activity. Okay, so it's 2:25 already. 3 minutes have passed. I would just like to ask, were you able to answer the guide questions?
Yes po, ma'am.
Okay, thank you so much. Very good. Let's now proceed with the second simulation. This one is called slab pull. So activity 2 is slab pull. The materials, we have the paper clips or necklace chain from the previous activity, pen, paper, and tape. And we'll be needing the edge of your table. So I believe you have table nearby, you can use that. Objective, understand the concept of slab pull. So here is the procedure. Hernil, kindly read the procedure for this activity.
Procedure. Use the paper clip necklace chain that you used earlier. Change the label of your chain to slab or oceanic plate. Number 2. Lay the chain on the edge of the table with one-third of its length, laying on the table and two-thirds hanging over the edge subdu- subduction zone. Number 3. Hold the first clip with your pointing finger, then release. Observe what happens.
Okay, thank you so much, Hernil. So for this activity, the chain will represent the slab or oceanic plate. The edge of the table will represent the subduction zone, and then you will observe what happens. So here should be the outcome of the model that you are doing right now. So here is the table. Again, the edge represents subduction zone, and here's your chain, and then it's labeled as the slab or the oceanic plate. Now, here are the guide questions that you should take note of as well for us to be able to process the idea or the concept of slab pull. Kindly read this guide questions. Jericho, seems like Jericho is having connection problems as well. So, Mary May Aureliado, kindly read the guide questions, please.
What happened to the paper clip, necklace, chain, slab, or oceanic plate when you released your hold on?
And number two. So for number two, the guide question is, what do you think caused the entire chain to be pulled downwards? So again, I'll be giving you 3 minutes to do the activity and answer the necessary guide questions for our discussion later. So it's 2:28 at 2:31. We will proceed with our discussion. You have 1 minute left to finish the activity and to finalize your answers to the guide questions. After which, we'll proceed with our discussion. Okay, so let's now proceed to our discussion. Let's answer the big question that we have a while ago. How do plates move? Let's start with the ridge push. So there are driving forces for plate movement. Here is the ridge push, and it happens right here on the mid-ocean ridge. So on your activity, we simulate the setting for the ridge push to happen. We use the folder. So the folder, as what you did on the activity, it represents the mid-ocean ridge. Now, I told you a while ago that your folder should look like a right triangle. So assuming that that is a right triangle, because it represents half of the mid-ocean ridge. That's the reason why um, I told you that the model should look like a right triangle. So let's process the guide questions that you answered a while ago. You added new chains. That's part of the procedure. What does the new chains being added represent in the ridge push, in the process of ridge push? Bitare.
It represents new ocean crust, ma'am.
Very good. So, new oceanic crust are created here in the mid-ocean ridge or in the oceanic ridge because this is where the magma rises and harden. So we have to take note that both of this crust, the new oceanic crust and the old oceanic crust, are already hardened since it's under the water and are really heavy. So they are heavy in weight. And they are also in a slope or slant, like in a slide in a park. So what happened to the paper clip labeled as the old oceanic crust? That's right here when you slowly added chains, what have you observed? Ivan.
Yes, ma'am. It it continuously goes down, ma'am.
Very good. So that's a very good observation. So the oceanic crust slides downwards away from the top, right? So now we know that the new chain represents the new oceanic crust. What happens when we add both of the weights of the new oceanic crust and the old oceanic crust? And also with their situation that they're in a slant. So what happens to the force of the push if we combine the weight of the new oceanic crust and the old oceanic crust? Kapundan, what do you think happens?
The new oceanic crust pushes the old oceanic crust.
Very good. So, very good. So that's what happens when the new oceanic crust is being added. It pushes away in a greater force the old oceanic crust. And that's the idea of ridge push. So let's now process this one. How does ridge push work? Ephraim, how does ridge push work?
Ma'am, the weight of
Yeah.
the
Mm-hmm.
the weight of the young oceanic crust and the slope of the mid-ocean ridge pushes the old oceanic crust.
Okay, very good. So that's what happens in the ridge push. Since And that's exactly what happens. The weight of the young oceanic crust and the slope, that means the slant, as what you've done on the activity, it pushes the old oceanic crust farther away from the mid-ocean ridge. So, and that's exactly how it works. Now, the weight of the new and the old, again, it pushes the oceanic crust downwards, and they go into the subduction zones that we can see right here. Right. So this is the location of the subduction zone. Once the oceanic crust moves farther away from the mid-ocean ridge, it goes here. And once it goes here, another process comes to rise, which is what we call the slab pull. Now, a while ago, you did an activity, a simulation, and you've used the edge of the table, which represents the subduction zone, and that's where the um slab pull happens, as seen in this one. Now, so let's answer the guide questions that we have provided a while ago. What happened to the paper clip or necklace chain, which is labeled as the oceanic plate, when you release your hold of it? So that's the first guide question a while ago. Here is the slab or the oceanic plate. What happened when you release your hold of the chain? Um, Amar.
Yes, ma'am. When you release your hold of it in necklace chain, the paper will fall down or slide down as the necklace chain.
Very good. So that's exactly what happened there. Next, what do you think caused the entire chain to be pulled downwards? Because Amar said that the entire chain was pulled downwards. What do you think caused that movement, that downward movement, Daphne? Okay. Christine, what do you think that caused that downward movement of the chain?
Because of the weight, ma'am.
Very good. So it's because of the weight of the slab or the oceanic plates. So remember that these chains represent the oceanic plate or slab. That's what I encircled here. If so, what happens then to the oceanic plate or slab at the subduction zone? And what do we call this mechanism? So what happens to this slab right here according to our activity? Hernil,
Ano po, ma'am?
what happens to the slab or oceanic plate right here? If we are going to relate it to the real thing here on the picture, this one, when the oceanic plate subducts, where does it go?
It will continue to go down.
Yes, and in which layer does it continue to go down? Which layer of the earth?
The slab pull po.
That mechanism is called the slab pull. And where does this slab go? In which layer of the earth? So we have three layers: the crust, the mantle, and the core. So where does this go? Which layer does this go?
Mantle po.
Very good. So the slab, which was pulled downwards, goes directly to the mantle. And since the mantle is hot, it will melt and becomes magma again, and the cycle will continue. Why? Because once it melts, it will go back up again because of convection current to the ocean ridge. So that's why there is a continuous plate movement. So ridge push happens, that it goes to the subduction area where slab pull happens, and then it's recycled. The oceanic plate is recycled in the mantle. It melts and then it rises again because of convection current to the oceanic ridge. So let's process now. So how does slab pull work? Toscano, how does slab pull work? Michelle, how does slab pull work according to your activity? Michelle? Ivan, do you have any idea how does slab pull work according to your activity a while ago, according to the simulation?
Hello, ma'am.
Yes,
The slab pull work. Wait lang, ma'am.
go ahead. What causes the oceanic plate to be pulled downwards? With your
The,
activity, di ba you labeled the chain as a slab or oceanic plate and then it was pulled downwards when you released your hold? What caused that?
it it goes down because of its weight, because it
Okay,
is hardened and
yes.
goes down to the mantle.
Very good. So that's exactly how slab pull works. So once a slab or oceanic plate subducts, it pulls the rest of the trail by its weight into the mantle. So now, this is the very reason why ridge push and slab pull are called the driving forces for plate movement, because as they continually um, do their processes for the ridge push and slab pull, it's located in the crust, and whatever is happening in the crust affects the entire plates. Okay, so here, what will happen to the plates? As I told you a while ago, the ridge push and slab pull, the ridge push and slab pull are happening on the crust. So what will happen to the plates, like the oceanic crust, if they undergo the process of ridge push and slab pull, arreliado? What will happen to the plates?
It will move or
Very good.
cause
So
earthquake.
yes, exactly. The reason why we experience geologic processes like seafloor spreading, like earthquakes, is because the plates are moving. And the two things that we have discussed today, which are the ridge push and slab pull, are one of the causes of this movement. Very good. Now, I have sent you a link a while ago. So visit the website menti.com and enter the code 673-66292. So I'll be posting this code for a while. Then afterwards, when you're all done entering your responses there, I'll be sharing with you the words that you have learned from today's discussion. Please notify me once you're all done entering or inputting the three words that you associate with ridge push and slab pull. Has everyone entered their responses? So let's have a look on your answers. Mm. Wow. Okay. So here are the words that you associate with ridge push and slab pull according to the concept that we have learned from our activities, experiments, and processing of the guide questions that we have a while ago. So number one, you have the subduction. Yes, that's good. And then you have weight. Exactly, because weight is one of the major factors why ridge push and slab pull happens along with gravity. Oceanic crust, very good, because these processes are happening in the oceanic crust on the ocean floor. Plate tectonics, very good. So because today we investigated what makes the plate move, right? So what causes plate movements, and that's plate tectonics. And it's caused by ridge push and slab pull. The mid-ocean ridge, very good, because the mid-ocean ridge is the site of seafloor spreading and the creation of new oceanic crust and ocean crust. Then convection, yes, because ridge push and slab pull are both continuous process because of convection. Very good. So I'm very glad that all the words you've put here, you have pull, push, then move, ridge, slab pull, mid-ocean ridge, everything that you've put here are correct. So good job to all of you guys. Now, let's proceed with assessments. Let's assess now your learning about ridge push and slab pull. I've also sent you a link for quizzes. So you may now start entering your responses. So here is the link, but I've already sent you the link so you can just click that link. So select the letter of the best answer. So you only have to select the a letter of the answer or the response which you think really explains or answers the question very well. And later on, we will be presenting your scores and we will be analyzing the scores in which items you find difficult or what help can we give to those who find the questions difficult. So go ahead and answer the quiz. All right. So now I'm seeing your scores. Five of you got perfect score. That's 5/5. A good job. And then one of you got one. I mean, got one of you got 4 points. So we have five students who got 5 points. Perfect. We have one student who got 4 points. And then we have four students whose scores vary from 1 to 3. However, there were students that I noticed had problems with continuing the quiz. Maybe it's because of the connection. And anyways, this quiz is set. It has no limit, so that means you can always retake the exam if, in any case, you had problems with your connection. But nevertheless, you did really good on this quiz. Now let's take a look at the questions and let's process these questions. Which questions did you find difficult? Okay. So for the first question, the correct answer is letter C. So that's the edge of the table, the mid-ocean ridge. Then, number 2, which of the following analogies in the ridge push simulation is correct? It's the folder mid-ocean ridge because for ridge push, the folder represents the mid-ocean ridge. The chain, it does not represent the continental crust or the convection. Of course, it does not represent the subduction zone because it's elevated. So the answer is letter B. Then, how does ridge push work? It's the weight of the uplifted ridge pushes the oceanic crust towards the subduction zone. Many of you got this answer. For 1, 2, and 3, most of you got it correctly. For the question number 4, this is where many of you failed or got the wrong answer. Maybe because you were confused with the words because they're very similar. So the correct answer is the subducting slab or plate pulls the rest of the trail by its weight. The second statement on letter B is incorrect because of the keyword pushes. We're talking about slab pull, so it does not push anything. The subducting slab plate does not do anything at all. Of course, it does, and it affects the rest of the trail. And letter D, the trail is pulling the subducting slab or plate. This is incorrect because the trail is the one being pulled, not the one pulling the slab or plate. So that's why the correct answer is letter A. And then lastly, why are ridge push and slab pull called driving forces for plate movement? Because they are both factors that initiate plate movement along with convection current as discussed a while ago. So all in all, you did a very great job with all the activity, the quiz, and everything, the processing of the concepts. Now, for those who got 3 below, you may watch this video. I've posted the link here and I will also send it on our group chat. So you may watch this. There's nothing to worry about if you weren't able to pass this quiz because it does not define who you are. And of course, you can always retake it and learn something from it. So here are the guide questions that you should answer as you are watching this video on the link. Number 1, what are the factors affecting the rate of ridge push and slab pull? And then number 2, do ridge push and slab pull really contribute to plate movement? How? So these are the 2 guide questions. I will follow up on you guys. I will PM you later individually so that I can help you with which concept you find confusing. So everyone, I'd like to thank you because you did a really good job. I appreciate your effort and really thank you so much.